Hello, this is Dr. Marion Carroll, and this will continue. I think we'll call this Lecture 5, Part 3. I did say we were going to continue with our discussion of isotopes, or conclude with our discussion of isotopes. Before we looked at isotopes, we looked at simply calculating the ratio, or I should say the percent of one form to the other. Okay, so this begs a definition. What is isotope? Isotope is the same element. However, it has different atomic masses or atomic weights. Different atomic weights or atomic mass unit. For instance, there are naturally occurring and man-made isotopes. For instance, sodium has an atomic number of 11, an atomic mass of 22, and there's also a sodium with an atomic mass of 23, an atomic number of 11. So these two exist together in the same element. One would want to know, under certain circumstances, what is the percentage of sodium 22 and what's the percentage of sodium 23. Alright. The examples I think we talked about before, you were given the percentages and asked to calculate what the atomic mass of each of these isotopes would be. In this case, let's look at carbon. Carbon has an isotope of 12 and 13. So that means the atomic mass of carbon 12.00, and carbon 13 is 13.00. If we had 98% carbon 12 and we had 1.1%, okay, so 98.9% we represent it like this. 1.1% and represented decimally like that. We simply would get 11.868 grams per mole of this is carbon 12, and this would be 0.143 grams per mole of the carbon 13. And when they add up, you should get the atomic mass unit that's represented in the periodic table. Alright, simple enough. Given the percentage, you can calculate by multiplying it by the isotope's atomic mass unit to get the mass of each individual isotope, which should total the atomic mass unit for the element. Well, the problem that we had consisted of this. If we did not know, we had an isotope, let's say chromium 52 and chromium 51. Okay, atomic number is 24 for each. So they exist together, elemental chromium. And the atomic mass unit for our elemental chromium that you'll see in the periodic table, 51.996. Well, if we wanted to know what the percentage of each one of these were, and we didn't, we can calculate that by setting up an algebraic expression. So much like what we did with carbon here, we want to take our atomic mass for chromium 52 and our atomic mass for chromium 51. We want to multiply it by its elemental proportion or percent composition here. But we don't know what that is for 52, and we don't know what it is for 51. And so what we end up with is an expression 52a and 51b. Well, like above here, when you add up the percentages, you should get 100%, right? Just like before. Alright, if we express that decimally, that's equal to 1. So if we express this decimally, 1.0. So now we can single out a variable by setting up an equality where one variable equals the other, and then doing a substitution. So what we're going to do is we're going to rearrange this equation. Remember, we add these together to get our final atomic mass unit for chromium. So if we added A plus B to get 1, we can rearrange it so that now we can say B equals 1 minus A. And when we do that, we can substitute in for B, which is now equal to 1 minus A. So now our expression is 52.00 times A plus 51.00 times 1 minus A. If we multiply this out, we're going to get 52.00A plus 51.00 minus 51.00A, because we simply distributed 51 to 1 and A minus A. And again, we're adding these up to equal our 51.996, which is our final atomic mass unit. If we add 52A plus negative 51A, what are we going to get? We're going to get 1.00A plus our 51.00. And that equals, again, this. So now this 51.996. So now we can rearrange and we can isolate our variable. We want to subtract 51 from both sides. If we do that, we'll have 1, let's go over here, 1.00A equals 51.996 minus 51 is equal to 0.996, and A then equals 0.996. You can divide both sides by 1. So now this becomes equivalent to A in our percent composition. So if we substitute 0.996 for A here, and now what is B? B is equal to 1 minus 0.996. Alright? And that's going to equal 0.004. Now we can substitute 0.004 in for B. Then when we do our multiplication, we end up being able to determine what the values are to add up to 51.996. Alright, let me see if I can take my little calculator here. And I'm going to say 51, turn it on, 51 times 0.004, that's going to be 0.204, and 52 times 0.996, that's going to be 51.792. Now if I add those two together, that's 0.204, what do I get? 51.996. So that was the calculation of the percent composition of our chromium 12, chromium 13 in our, where are we? Yeah, chromium 12. Here, that's carbon. This is chromium. In our total atomic mass. Okay. Alright, that concludes part 3. We're going to move on and talk about bond formation. Alright. Talk to you later.